So far what we've worked with are linear functions. Okay, so in other words, when they are graphed, they make a line. And remember that in math, all lines are straight. Okay, so in other words, outside of math, well, that's a line. Okay, but it's not in math. That is a curve in math. So remember, when we say line, in a math context, it's always a straight line. In fact, we could go one step further and actually tell you there's no such thing as a line. It's just a straight curve. But that's too hard to say, and we are lazy math people. So what we are going to call this is a line. And if we say line in math, it's always straight. Okay, it can be vertical, it can be horizontal, it can be diagonal that way, whatever, it doesn't matter, but it's always straight. Okay, so what we want to introduce today is something called exponential functions. So an exponential function, you'll know when you see it that it's exponential because your variable is up in the exponent. Okay, your variable will be up in the exponent. So for instance, if I tell you y equals 1.3 times 4 to the x power. Okay, where is your variable? My variable is in the exponent. So this is an exponential function. Okay, my variable is in the exponent. There's one other way for numbers to grow rapidly following a pattern that's faster than exponentials. So what did I just say? I can say, so, and I'm just going to use 2 for example. I can say 2 to the 0 power. Okay, remember that any number to the 0 power is 1. Okay, well, I can increase my exponent, and now 2 to the first is 2. So increase it again, and 2 times 2 is 4. Increase it again, 2 times 2 times 2 is 8. Okay, so I've got this, and just by following a pattern where I increase by 1, these numbers grow really big, really fast. Okay, so there's another type of there's another type of number called a factorial, which is actually an exclamation point. Okay, that's called a factorial, and that's the only other way following a pattern that numbers grow faster than exponentials. Okay, so exponentials are the fastest way to make a number grow other than factorials. So again, I could say 2 to the 7th, and that's going to be 128. I could say 2 to the 8th, and that's going to be 256. I could say 2 to the 9th, and that's going to be 512. I could say 2 to the 10th, and that's going to be 1024. So again, all I did was increase by 1. And I just did it 10 times, and I grew from 1 to over 1,000. Okay, so it's the fastest way for numbers to grow. Now, if we're graphing, we want to look at a couple of different things. Okay, so if we're graphing exponential functions, if our base is improper, okay, if our base is improper, meaning the top number or the numerator is bigger than the bottom number or the denominator. So bigger over smaller. So this is improper. I could also say that 7 is improper because I can write 7 over 1. Okay. If your base is improper, your graph will increase as you read it from left to right. From left to right. So what does that look like? What that looks like is this, is I'm reading this thing and I'm walking it across from left to right. It's going to shoot up like that. So reading it from left to right, what is the curve doing? The curve is going up or increasing. Okay, so if your base is proper, so for instance, 1/3, okay, top is smaller than the bottom. Improper, it's bigger over smaller. Proper is smaller over bigger. So if it's a proper base, it's going to decrease as you read it from left to right. So it looks something like this. It'll drop down and then get really, really, really close to that axis as you go. So as you read just this curve, as you read that from left to right, what is the curve doing? It's dropping down. Okay, so that'll decrease. And then you're guaranteed 2 points on every exponential function unless we move it. So 2 points are going to be base, comma, 0. Okay, base, oh, that's a, shoot, I am so sorry. Hang on, that's a lie. 0, comma, base, hang on. I had to get my brain in order, sorry. Every exponential function will graph through the point 0, comma 1 unless we move it. Every exponential function will graph through the point 0, comma 1 unless we move it. So this point right here is 0 because I didn't move left or right, and then I went up 1. Okay, why is that? Because I've got 2 raised to the 0 power. Any number to the 0 power is 1. So if I shove in a 0, it's going to pop out a 1. Okay, if I shove in a 0, it's going to pop out a 1. The other thing that everything has is base, comma, 1. Okay, so sorry, I was morphing those two together. All right, so base, in this case, my base was 2. Okay, if I raise that to the first power, okay, I will end up with, I just, see, I'm telling you the answers. Hang on, I am so sorry. All right, if I have 1 comma base, okay, if I raise my base to the first power, what do I get back? I get the base. Land of Goshen. I need to stop looking at this and just go with my brain. So what do I have here? If I go over to 1, I would have graphed the point 2. Land of Goshen. All right. If I would have plotted the point 1, I would have gone up to 2 because here's my 1 and it popped out of 2. If I had done this one, which is 1/3, okay, if I had shoved in a 1, well, what is any number to the first power? It's itself. Okay, so if I'd shoved in a 1, it would have plotted out at 1/3. So 1 comma 1/3 was on that graph. Okay, so summarize because my brain is scattered. If I'm graphing and my base is improper, I know that he'll increase as I read it from left to right. I also know that unless I move that graph, that the point 0, comma 1 will be on the graph, and 1 comma base, whatever my base is. In this case, it was 2. In this case, it was 1/3. 1 comma base will be on the graph. If I'm graphing and my base is proper, in other words, small over big, okay, then I still know that 0, comma 1 is on that graph. I still know that 1 comma base is on the graph because if I raise it to the first, I get this back. Okay, and I also know as I read it from left to right, it'll be decreasing. Okay, so we're going to work on, in section 4.1, we're going to work on what this means and how this works. Okay, and give you some graphs to work with and give you some word problems and some application problems. So that's what part 2 will be.